Hi, let us start in 1 more minute. Okay, so I think we can just resume from where we left last time. So just a minute. Okay, so we were doing this problem. So let me just go over this from the beginning. So yeah, so this was basically one of the problems where some of the information is given in terms of trigonometry and some information is given in terms of ratios. So we have started to look at this problem. Basically, this cos of angle ACB we wanted to use, and so we were trying to figure out which perpendicular we want to use. So initially, we started with this approach of dropping the perpendicular from point B, uh, but then we got stuck halfway between from that. So later on, I was able to complete this approach also, but let me come back to this later. The second idea works much easy, so maybe the better to think about that first. So if we drop the perpendicular from A, and if I call that length as h, then because of the cosine, we can find the in terms of h, we can find the three lengths of this triangle ASC, right? So we get AC as 5h by 4, and as we get CS as 3h by 4. And so therefore, we are everything to apply Pythagoras theorem in triangle ASD, because we have the ratio AD upon AC also, right? That is also given to us. So therefore, we can find the length of AD again in terms of h. So therefore, finally we get the equation like a square plus hd square, so is equal to ad square. And so if we substitute all the expressions which are in terms of h, we get this overall expression. Uh, okay, so I hope everything up to this point is clear. Any doubts about how we got to this equation or any other questions? So then now we have to just solve this equation. Okay, so so even in solving this equation, we somebody might try to expand this whole thing and then solve it that way, but actually it can be done a little bit more efficiently, because if you observe this, like what is the RHS, it is 25 h square minus by 9. And so if I take this h square on the other side, right, basically it is going to become a perfect square on the RHS also. So I'm going to get, okay, so this is 16 h square by 9. So both LHS and RHS are perfect squares, so I can just take the square root directly. So I'll get 3h by 4. And in general, whenever you're taking the square root, you have to be careful that are you taking the positive or the negative square root. But in this case, because everything is positive on the both left and right hand side, so I think it is safe to assume that it has to be the positive square root. Uh, okay, and so from this we can get the value of h. If I multiply everything by 12, I will get. Sorry. Sorry.
16 किंवा एवढी कमी हा 5% जाते आवाज काय नाही कळलं पण काय नाही त्या दिवसाचा ते क्वेश्चन
अरे म्यूट हे काढलं तुम्ही. Okay, so h is equal to 12. Okay. So once we get the value of h, then everything else we can find, right? Okay, so if I go back to my original diagram, then in that, or let me draw it again here. So what we found right now is the height, which is 12. And then from that, we can find all the remaining lengths, right? So A, B, S, C, D. C, D is 7 dilas already. So how much is CS? CS is 3S by 4. So therefore, that is basically this triangle is in the ratio 3 is to 4 is to 5. ते आपण मागच्या आपण बघितलं होतं, right? So therefore, once we know one side, we can find the other two sides. So this is 9, this is 15. Then total BC is given as 14. बरोबर? त्याच्यामुळे this is also 5. And then by Pythagoras, you see this third side has to be 13. Okay, so एक लेंथ मिळाली की बाकी सगळे पटापट मिळतात. Right? So once you get the height h, we find everything else. And what are they asking in the question? Let me check that. Find AB. Right? So they had to ask AB, which we have found as 13. Okay, so yeah, before we proceed, just I will pause for 1 minute if there is any question. Okay. So again, just to quickly go through the important steps. So we assume this altitude is h, then we use the ratios in this triangle to find AC and SC in terms of h. And then we use this the ratio that is given AC upon AD to find AD also again in terms of h. We put everything in the Pythagoras theorem and then we solve for h. Okay. So now the question is, what if instead of dropping this AS, is there any other method? So interestingly, there is one more method, and the thing to highlight, I feel, is that this method I last time, so we already had conducted this batch once. There also I solved this problem, but there I did not find this method. So when I was trying to solve this problem again, this new method came to life. And so this is important because for you to also think about this, that whenever you solve a problem, don't just immediately move on to the next problem. Spend more time with that problem, that are you able to find some new trick, some new idea which you may have missed before. uh, like try to find multiple solutions to the problem. Okay, don't just try to solve it in one way and move on. So the other idea which I found was like this. Let me just draw the diagram again. See, the reason why this idea failed, right? What we tried last time, you should even understand it. Why that idea did not work. So we tried to put this perpendicular. I can imagine that why we were tempted to try this perpendicular, because BC ची length दिली आहे ना आपल्याला 14. So we can quickly make progress, and here BT and CT we can find. But where we got stuck is that the AC upon AD, this other information, right? AC and AD ह्याचं आणि ह्या ट्रायंगलची काही संबंध नाही. So we need some way to connect this triangle with AC upon AD. Only then we can make progress, right? So that is where we got stuck with this approach. Okay. So there are two ways to you know solve this problem. I will suggest one idea. I will not completely explore it, but suppose I draw one more perpendicular like this. Okay. So this is the perpendicular from B to AD. Okay. And let this could be some another point K, suppose. Okay. So, what is going to happen? What is the point of this one more perpendicular? So if you look at the area of triangle ABC, okay, we write that is half base into height, and I will use the base as AC, right? So half area of ABC will be half into the base into height. Okay, and same I can write the area of triangle ABD also. Okay, that is also half into. So here the height is BK and the base is AD. Okay, and what is the point of writing this to area is that uh, if you realize that actually these two triangles have whenever you have a triangle, right, you can find its area in multiple ways, right? You can take this as the base and this as the height, or I can take this as the base and this as the height. So every combination of base and height will give me the area. So in the, if I can also write the area of these triangles, if you notice, these two triangles have the common height. If I use BC as the base and BD as the base for these two triangles, right? Then like this is a common height, the third height, right? Which was H in my right diagram. But here that is a just observing that they have a common height here. So if I write the area also as half into, for triangle ABC, it is half into base BC into height. So if I'm calling this small h, and for this it is half into BD into H, right? Uh, and now if I see, I can take the ratio of both, right? So if I divide this and equate, and see, lots of things are going to get cancelled, and ultimately what I'm going to get is just so see, all the half will cancel. I'll have AC upon AD, whose value I know because that is given to me. Okay, and on the right hand side again, H will cancel, and I'll have BC upon BD. Sorry, okay, sorry, BC upon BD again, which value I know, that is 14 by 20. Sorry, let me just adjust some settings. हे बटन चुकून दाबलं जाते, त्यामुळे ते काहीतरी वेगळं होतं. Okay, so you see, I know AC upon AD, I know BT because that is what last time we were able to find. So therefore, I can find BK and so on and so forth. Okay, so I mean, I will not complete this proof right now, but just as a homework for you to think that how this idea can also be taken forward. But mostly, I will. मला तरी हे जास्त complicated वाटते की this is not very easy to observe and find the answer. Compared to that, the right hand side solution was much more easy to navigate. So you see that simple choice, that which perpendicular you draw to use that cosine value, that can make the difference between whether you get stuck in a problem or you are able to make progress. Okay. So make a careful note of all of these. Okay. Any other question about this one before we proceed?
No, sir.
Okay, so let me go ahead. Okay, so these were the two questions related to trigonometry that we did. So now I think the next topic is I don't know, some area related formula, nothing specific as such, just generally knowing area formulae should be sufficient to solve this problem. Okay, so so one more thing I think we should learn is how to draw the diagram properly. So like for example, if you read this information and if you just start from the beginning and you just read, okay, it's a trapezium ABCD and AB parallel to CD, and if I just draw any trapezium without reading the rest of the question, okay, then I will have to again redraw the diagram because the next thing I read is AB is at a right angle, which is not in my diagram. So, drawing the diagram in such a way that, you get it accurately with all the information captured. That is important. Okay. So, uh, so in that regard, read through the question properly and then start drawing. You don't have to necessarily start from the first line. Okay. You can, for example, I'm thinking to draw this diagram like this, that what is given angle at B is a right angle. So I will just draw angle B as a right angle without committing the position of A and C. I'm just drawing B as a right angle. Okay. Then if I proceed, it's a diagonal BD is perpendicular to AD. Okay. So then I will start to add more details. That okay. Suppose I will assume, and again I want to be careful and make the diagram as general as possible, right? If somebody draws the diagram like this, nothing wrong with it, but it looks like a 45, 45, 90 triangle, which is not given. So again, you might be misleading yourself into some information. So always better to draw it in a more general way, like maybe draw it something like this. Okay. So therefore this, so now we have all the information established. Okay. So ABCD is like this. And so this was the 90 degree that was given. The length of BC is 2. The length of diagonal BD is root 13. Okay. So apparently it looks like just two lengths are given, but from that we are supposed to find the area of the trapezium. Okay, so can somebody tell me how to proceed in a question like this?
Sir, in first triangle, we can use Pythagoras theorem to calculate the DC side.
Yes, correct.
Then by similarity test, we can prove that this first angle is similar to second. And then
Correct.
we get the ratios of the corresponding sides. And then by equating, we get all other sides.
Yes, correct. So the thing which is given here, the 90-degree angles, we have to use them to observe that if, for example, if I mark this as a dot, right, angle CBD, that is a dot, then the remaining angle, this one is a its complement, right, 90 minus that, and again the complement of the complement will again be equal to the original angle, right? So therefore, angle BAD, which is 90 minus angle ABD, and then and which is the same as angle CBD. Okay. So therefore, so which two triangles are similar? Like so, this is also 90-degree at the bottom because of parallel lines. So triangle BCD, and pay close attention to the corresponding. That when you write similar triangles, the order is very important. That if I am writing the first triangle as BCD, then the wherever the dot is coming, right? So B is where the dot is there. So that has to be the vertex A, and after that C is where the right angle is there. So therefore the second vertex has to be T, and finally right, so B, because that is the cross. Okay, so that order is very important, otherwise you will get your correspondence incorrect. Okay, so if these two triangles are similar, then we can write the ratio. So by the way, even before that, so we were able to find CD with Pythagoras theorem. So CD will be simply square root of 13 minus 4, right, which is 9. So that is 3. So therefore, we know all the three sides of the first triangle, and then we should be able to correlate that with the second triangle. Yes, Prasanna?
Sir, we have not given that angle DCB is right angle.
No, but we are given that AB is parallel to CD, right? And so if this angle is 90-degree, will because of that, what, because of alternate angles, this will also be 90 degrees, right?
Yes, yes, sir.
Okay. So therefore, now if I write ratios of the sides, so I'll get BC upon AD. Okay, and so this should help me to find the remaining sides. So for example, I want to find AB, and actually I don't need AD, right? AD is not important. I What I want to do is find the area of the trapezium. So for that, what AB, the length of the parallel sides, and the height, that is the information I need. So I'm only interested in AB. So if I take these two terms and equate them, then I have all the information, right? So I'm going to get AB is equal to BD into DB upon CD. So I can just calculate that. Oh, oh, sorry, it is, yeah. So it's actually BD square. Okay, so AB is 13 over 3. So therefore now I can just find the area. So the area of the trapezium, which is they denoted as by delta, is half into the sum of the parallel sides into the height. So in this case, the height is also this 2, right? BC, because this. So you see, this perpendicular information is giving so many, utilization, that it is also the height of this trapezium. It is also enabled us to take this 90-degree and deduce that this is also 90-degree, and that 90 degree also helped us to chase these angles. So one information is able to lead into so many different further information. Okay, so now this is just calculation. So then I'm going to get 22 by 3, right? So delta is 22 by 3, therefore 3 delta is 22, which is what they had asked for, right? Yes. Okay, so I think once you notice this trick of chasing angles, the rest of the calculations are fairly straightforward. Okay, any questions about this one? So always in a question like this, after you finish solving the problem, as I said, try to construct your own new problem. That's what if some other information was given. Like again, let us draw the same diagram. Okay, so this is how you generate more practice again. That let us say I give you the same information of the angles. Okay, but this time I give you different information about the sides. Let us say that, for example, I give the length of AD and I give length of BC. Then can you solve the problem? So like that, you have to challenge yourself to ask all of these questions that what all I can do. Yes, Atharva.
So can you explain once I was disconnected?
Okay, okay. So, very briefly, the idea is that what is the information given is that there are two right angles here. So this angle B over here and this base angle, which are 90 degrees. Because of that, this we can chase this angle. So the green dot which I marked over here. So that will be equal to the complement of that will be this angle, and then the complement of this cross is again this angle, right? So basically, complement of complement will be equal to the original angle. So therefore, this angle CBD is equal to angle PAD. And so therefore, what we get is two similar triangles. So triangle BCD is similar to triangle ADB. Okay. And therefore, we can write the ratios of the corresponding sides. And particularly, we are interested in finding the length of AB, because why we want the area of the trapezium. So for area, we need the two opposite sides and the height. And so that now AB we are able to find in terms of everything else. And then once we get AB, we substitute that into the area formula and get the answer. After that, it is straightforward. Okay. But as I was just saying that, just finding the answer is not sufficient. You have to think about what you can do further about this question. So, for example, what if you ask this question that, so same information, suppose BC is given as 2 and AD is given as, so in this case, what is the value of AD that we get? We did not calculate that. Uh, whatever it comes, doesn't matter. Let's say it comes to be 5. Okay. So then if this is given as 2 and this is given as 5 and all the other information is the same, now can you find the area of the trapezium? So, try to challenge yourself in different ways like this. Only then you will be able to, understand the problem from all directions. Okay. Any other questions? Okay. Not then we can go to the next problem. Okay. So what is given? So again, there is some information given, but don't be in a rush to draw the diagram. See, what is given, x, y, z are on a circle with center O, such that z and O are the opposite sides of chord x, y. So if as a first attempt you draw a very rough diagram, you might want to draw something like this, that O and Z are on the opposite side of the chord x. So I've just drawn O and Z. I have not drawn x, y somewhere in between yet, because if I continue to read the question, what I'm getting, that AB are on x, y, such that OA is equal to OB is equal to ZA equal to ZB. Okay, so uh, these AB points are somewhere such that if you notice how it is that OA and ZA are equal, which means you must have already studied this in school, that when a point is equidistant from two other points, it has to lie on the perpendicular bisector, right? So if this is my O and this is my Z, then if OA and ZA are equal, so therefore the diagram has to look something like this. That if I draw the perpendicular bisector of OZ, then A should lie on that. And same for B also, right? Because OB and ZB are also equal. So in fact, these 4 points O, A, B, Z, they are going to form a rhombus, right? Because all the 4 lengths are equal. So with that, background knowledge or observation, you can quickly draw the diagram accurately in the first attempt. Right? So you draw OZ, you draw the perpendicular bisector of OZ, right? And then that is the line XY. So therefore, these are the points X and Y. So you see how changing the order of drawing the diagram, instead of drawing X and Y first, I selected X and Y last. I drew everything else first. Okay, so you see how you can change the order that. Okay, and then okay, and then you have to mark this A and B also. Make the diagram slightly larger. Okay, so you see in this diagram we are capturing all the important information that all these lengths are equal, and we also know how much that length is, right? So all of them are equal to 5. And you see, this is how the question paper will try to trick you, that nowhere what is directly given that this is a rhombus, OAZB is a rhombus, but based on your knowledge and observation, we are deducing that this is a rhombus, and therefore that leads to all these properties that the diagonals bisect each other, and therefore this AB is the sort of the half line between O and Z. Okay, okay. And then what else is given? XY is 12. Okay, so we know that XY is 12. But now if you observe that, again, we are relying on a concept of symmetry, which we have seen so many times that, uh, you know, even without proving it, do you see that if I label this point as T, then T is the midpoint of XY. Okay, T has to lie halfway between X
Sir,
and Y.
it is theorem also that if the line is perpendicular, then line it is midpoint.
Oh, this is a theorem which already you know. Okay, that is very okay. So in either way, that even if you don't know the proof, you can prove it also. It is not difficult. So therefore, basically what it means that xy is 12. So half of that xt will be 6, right? Okay, so I know this length is 6. Okay, and okay, what else? And I want to find AB square. Okay, so I am interested in AB square. So if you'll notice, AB square, if I find 80, then double of that will be AB. So So the only thing I need to find is 80. Okay? So once I find 80, I will get the answer. Okay, and then the last thing that to be observed is that in this, if I join OX, right? So that is the radius of my circle. So if I call it R, capital R. Okay, so let the radius of the circle be R, or let me use smaller, not capital R, because just for the vertices we are using capital letter. So that is also the radius OZ, right? So therefore OT, which is exactly half of that, right? So OT, which is R by 2, because why? Again, T is the midpoint of OZ. So what can you observe about this triangle OTX, right? One side is R, the hypotenuse is R, and OT is R by 2. So what can you say about this triangle?
So 30, 60, 90 triangle.
It is a 30, 60, 90 triangle, right? So you see, we know 30, 60, 90 property in a reverse direction, that if I know the angles are 30 and 60 and 90, then I know that this side is half of the hypotenuse, right? So if the hypotenuse is whatever h, then this is h by 2. But the property goes in the reverse direction also, that if I have a right angle triangle where one side is half of the hypotenuse, then it has to be a 30-degree angle opposite to that. So you are using the sort of, I'll say, converse of 30, 60, 90 property. Okay, so again, may not have realized that it can be used in this reverse direction also, but here it is implied that therefore what we can say is that this angle OXT is 30 degrees and angle XOT is 60 degrees. Okay. Okay. So therefore, what will that allow us to do? Because we know the length of xt, right? Xt is given as 6 over here. So if OX is R, xt will be root 3 by 2 times R, root 3 by 2 times the hypotenuse, which is R. And so that is equal to 6, which is the given information. So therefore, we are able to find the value of R. By the way, even if you did not realize the 30, 60, 90 property, you see by simply by Pythagoras theorem also you can do the same thing, right? Basically, OX square minus OT square will also give me XT square. So you don't have to rely on that 30, 60, 90 observation to do this calculation. And so now, therefore, I'm getting the value of R as 12 by root 3. Okay, or if I clear the denominator, it is 4 root 3. No, sorry. Yes, 4 root 3. Okay, so that is the value of R. Finally, what do we have to calculate? We have to calculate AB square. So we want to find 80. So I think we can do that now, right? We have all the information to do that because in triangle OAT, I know so AT square will be OA square minus OT square. So therefore, and OA is given as 5 and OT simply R by 2, right? So therefore, I'm getting so AT square is 13. And what are you supposed to find? AB square. So AB square will be simply 4 times AT square, right? Yes, the answer is 52. Correct. Okay. So what was the key observation because of which we were able to complete this problem? So two things. One is that realizing that this is a rhombus, and the sort of the diagonals bisect each other. So the xy is nothing but the half line between O and Z. So therefore, if we get this length, the radius as R, then the OT is exactly half of that, R by 2. And because of that, we are able to apply Pythagoras theorem or using 30, 60, 90 property. Either way, to get xt, use the length of xt to find the value of the radius. And then once, so you see, all of these problems have a very typical pattern that once you find one important length, like for example, here we found R, then after that, substituting that and finishing the problem is relatively straightforward. Similarly, in one of the previous questions, right, when we find one length, we can substitute that and find everything else. Okay, so this is like almost like a two-step problem, all of these, that find that critical information and then use that to simplify the remaining diagram. Okay. So we are not used to these kind of problems in school. That is why it may seem a bit more, it may seem difficult, but it is not really difficult. I'll say uh, it's just more, it's more complicated. Difficult is not the right word, I'll say. It's just trying to make things appear more complicated than they actually are. Okay. Any other questions about this one? Okay. So I think we are coming almost to the end of the geometry section. So I think these are the last two problems left from geometry. So this question 30 is actually interesting. It's a 3D problem. So 3D geometry is a completely different, study as such. And in school, typically we don't have a lot of 3D geometry. Of course, you must have found know the formula for the area of a cylinder or sphere. So those kind of some basic formula, but we don't really have a lot of experience with 3D geometry. But the thing is, I mean, at least for this exam, what I can guarantee is that even if there is any 3D geometry question, right, they are just trying to test your basic knowledge of can you apply Pythagoras theorem and things like that. Because even if there is a triangle which is not in the plane, but it is in a 3D space, so there also the Pythagoras theorem can be applied for any right angle triangle. So in that way, you don't need to know any advanced theory. You just need to apply what you know properly. So let's say for this question. So first thing is it is a regular tetrahedron. So uh, have you already studied what is a tetrahedron in school or maybe for chemistry also? So it is a
Yes.
kind of a extension of a triangle, right? So it has a triangle at the base and a vertex at the top. Okay, and in general, just like you have any normal triangle may or may not be equilateral. So in general, tetrahedron does not have to be regular. But if it is given that it is a regular tetrahedron, then it has some special property. Okay, so the first special property is that all the lengths are equal. Okay, so all the sides are equal. So if I call this A, B, C, D, so all the so what are called edges. Okay, so all the sides like AB, AC, all these segments are equal. Okay, and as a result of that, what happens is all the faces, right? So what is a face? Face is like one surface, right? So ACD is, for example, one face. Are equilateral triangles. Okay, so all the faces are equilateral triangles. Okay, so this is a one of what is called a regular. Just as you have regular polygons, right? So there is a concept of a regular polyhedron. Okay, so these are all the sort of very nice diagram that it is perfectly symmetric, right? So you see the word symmetry keeps coming back again and again. That this is a very nice diagram. That from any side you look, it looks the same. And really appreciating the symmetry of this regular tetrahedron is very essential. Okay, to understand, like basically, if I show you what does a polyhedron look like, then you realize that so by the cube is also called a regular polyhedron. Okay. Oh, I thought I had that. Anyway, maybe next time I'll show you the. I want to show you there are total of 5 regular polyhedrons, and all of them are very interesting properties. And so the important thing is symmetry. So we can make use of this in this problem because if I look at this right now, looking at this from the side, like some random angle, so it is not clear what is happening. But if I look at this from the top, right, so perfectly from a top, it will look like this. So imagine that you are standing exactly above and trying to look at the diagram. So it will look something like this. So all the so this is what you see from the top is the base equilateral triangle BCD, and all the vertices are joined to the central vertex, right? So when you look from the top, you don't realize that this point A is actually floating above the ground. So it is at some distance from the ground. But from the top, it looks perfectly like this. Okay. So like equilateral triangle and everything connected to the center. That is what the diagram will look like. Okay. And in the question, what is given? This AG is also given, right? So AG is the perpendicular over here, right? If I drop a perpendicular from the point to this bottom face, then that is AG. But when you look at the diagram from the top, you see that A and G are going to be perfectly coincident, right? You will not see them as two different vertices, but they will seem like they are overlapping. Okay. So this is what the top view looks like for this diagram. Okay. So why is this important? Because now if you realize what is the question asking, by the way, find the distance of A. Okay. So we are given the length of the side, right? We are given the length of when you one length is given, it means all the lengths are given, right? So all the lengths are of that whatever 5 roots. Okay. So all the sides of this my equilateral triangle are of that length. Okay. And I want to find uh, AG. So in this diagram, if you realize, if I join G to any of the vertices, let us say join it to D. Okay. So I'm going to get this right angle triangle AGD. So if I apply Pythagoras theorem, I will get the length of AG directly, right? So for that, what do I need to know? So I need to know the length of AD. Do I know the length of AD? Yes, right? That is 5 roots. So if I find the length of GD, then that will give me the information to find AG. So how do you find GD? So that is where this top view helps, because now if you look at this from the top view, it is clear that this GD is nothing but connecting. So we all know that, if I extend this, it will become median, right, for this triangle. So GD is just, 2/3 of that median. So I can find the length of GD directly. Or if you remember at the very beginning, I had told you to that this is one special triangle. Remember this special triangle of 30, 30, 120? Just like 30, 60, 90 triangle, this is also a special triangle. Actually, it is nothing but just two 30, 60, 90 triangles connected to each other. Okay, but the property is that the lengths are in this ratio 1, 1, and root 3. Okay, so therefore, if I know one length, I can find all the other lengths. So here you see that is exactly what we have. Like this is isn't this a 30, 30, 120 triangle? And I know one length. This is 5 roots, right? So therefore, I can quickly find the remaining length. So for example, here what will be GD will be equal to 5 root 6 divided by root 3. Okay, so therefore it is simply 5 root. Okay, so GD is 5 root 2. So therefore, if I go back to my top diagram, I know now GD is 5 root 2. I know AD is 5 root 6. So therefore, now AG is just Pythagoras theorem. So AG square is AD square minus GD square, right? So 150 minus 250, right? So AG square is 100. So AG is 10. Okay. So you see, looking at this diagram from the top was very helpful. That immediately you realize that this GD is nothing but just the distance of this center of the equilateral triangle to the one of the vertices. Okay. So this kind of question definitely requires you to stretch your imagination a little bit, because you never thought of this, like how the same diagram looks from different angles. That is what this question is trying to test in some. But the actual calculation is just Pythagoras theorem, nothing else. Okay, so I mean, to some extent, you should be prepared for this kind of question. I don't think it will be very emphasized. Like even if you get a question, it might be at most one question of 3D geometry. And of course, in the practice test, I'm going to give you today. There also you will have some. I think there will be one 3D geometry question there also. So that will give you some practice. But don't worry too much about the 3D geometries. Okay. Any other questions about this one? Okay. If not, then okay. So then this is the last geometry question that we have to discuss.
So how GD is 1/3 of AG, or like
Yeah. So GD is 1/3 because in this triangle, right? What are the angles? The angles are 120, 30, 30, right? Uh, so uh, so what is the standard property which we are using here is that in 120, 30, 30 triangle, this largest side is root 3 times the other two sides. Okay, and you can easily derive this using, if I drop this altitude, I will get two 30, 60, 90 triangles. So I'm skipping the proof of this. But yeah, so the property which you can remember is that this length, whatever is this length, this is root 3 times that. Okay, so if this is k, then this will be root 3 times k. And so therefore the reverse is also true, right? So if I know this length, so in this case, this length was given as 5 root 6, right? So therefore each of the two other side will be 1 by root 3 times of that. So therefore GD was 5 root 6 divided by square root of 3. Okay. Okay, then question 22. So in some way, at least my own rating was question 22 was definitely one of the hardest geometry questions. And so despite that, I already mentioned this last time that it is a second question. So if you spend too much time on this one, you might actually miss the opportunity to apply to solve other questions. So what is given is that, so there is already the first information looks very complicated, right? 12-sided regular polygon. How do I draw it properly? But luckily, if you look at the rest of the question, you see that actually they are not using all the vertices of this 12-sided polygon. In fact, the only vertices which are even mentioned in the problem are D, E, F, and N. Okay, so basically, and because it's a regular polygon, I can start from the end. So let me construct only the last few and the first few vertices of this polygon. I will not draw the whole polygon. But by the way, so it is a 12-sided polygon. So firstly, how much is the uh, angle? How do I find the internal angle at each vertex?
N minus 2
So
into 180 upon N.
yes, correct. So I mean, in case anybody doesn't know the formula, the idea is that what is the external angle, right? So if I say the external angle, you know that the sum of all the external angles has to be 360. This is a standard property of any polygon, that the sum of all the external angles has to be 360. And therefore, if I have 12 sides, so therefore 12 times the whatever is the value of the external angle is 360. Therefore, the value of the external angle is simply 30 degrees. Okay, and therefore, if external angle is 30, then internal angle will be the supplement of that. Okay, so therefore it is 150 degrees. Okay, or you must have already found the formula for finding the internal angle. You can directly apply that. Okay, so given that all the external angles are 30 degrees, so this is how I will draw the diagram. That's if I start from one segment. So let's say I start from MN. So this is MN. Okay, so then from N to O, I have to make a 30-degree turn, right? So from imagine that I'm walking from M to N and take a right turn by 30 degrees. So this is O. Then again for the next vertex, so after O, I'm coming to D. So I have to take another 30-degree turn. So this is D. And then from D, again I have to take a 30-degree turn. So you see from M to E, I have taken three 30-degree turns. So therefore total turn I have taken is 90 degrees. And so in here also it is reasonably looks like a accurate diagram, right? So and then I have to proceed from that because I also need point F. So one more 30-degree turn. Okay, so this is the I will not draw the whole diagram, the whole 12-sided polygon, but this is the only part which we need to know as such, or we need to concern ourselves with only these vertices. Okay, and then what is given outside of this, square BCDE is constructed. So on the segment DE, we are constructing this square. Okay, and then further on side BC, another equilateral triangle is drawn. Okay, so this is the whole diagram. So you see, it looks already very complicated. The first is a 12-sided polygon. On that, on one side you're drawing a square, and on that you're drawing an equilateral triangle. And so one important thing is, because all of these are regular polygons, so all the lengths are equal, right? So all of these lengths, this is also square, this is also equilateral triangle. So all the lengths are equal. Okay, and we are interested in the circumcircle of AFN. So which are the 3 points? A is here, F is here, N is here. Okay, so I'm interested in the circumcenter of these 2 points. Okay, so you see, I mean, looking at the diagram, uh, even for me, honestly, when I started to look at this question, at first I was not able to make any progress at all. Then what I started to realize is, so I want the circumcenter of, so I'm interested in the circum radius. of triangle AFN. Okay, so first, before finding that, the question is where is the circumcenter located? So where is the circumcenter? Okay, and what is the circumcenter? It is the point which is on the all the three angle perpendicular bisectors, right? So if I drop the perpendicular bisector of AF, FN, and NA, wherever they meet, that is where the circumcenter is going to be. So out of all these three perpendicular bisectors, for me, what I realized that the perpendicular bisector of Fn is very easy to realize that because why? Because this is a regular polygon, right? So here, because all these lengths are equal, so in fact, the perpendicular bisector of Fn passes through D. Okay, so you see the perpendicular bisector of Fn goes through D. Okay, so that was a hint that maybe can point D itself be the point where all the three perpendicular bisectors meet. And for that, I mean, if you just look at the diagram and you realize that in fact the second perpendicular bisector, right, for an also. So if I join this segment OCO, you'll see that through the angles that this is a straight line. Why? Because this angle is 30 degrees, right? So this angle is 30 degrees. Why? Because that is the external angle of my 12-sided polygon. And this is 60 and this is 90, so therefore the 60 plus 90, so that will become, this is also 30 degrees. Okay, so therefore this ONCA, this is actually a straight line. And then if it's a straight line, then again the perpendicular bisector of AN can be easily found, that where the midpoint of AN is going to lie. So it is going to lie exactly at the midpoint of OC, right? So again, if I draw the perpendicular bisector of AN, it is also going to pass through D. So the perpendicular bisector of AN also passes through D. So therefore, if two of the perpendicular bisectors pass through D, then that confirms, right? Therefore, D has to be, we don't have to find the third bisector. We already know that all the three bisectors are concurrent. So therefore, D is the circumcenter of triangle AF. Okay. I saw the official solution. They have also given, of course, there is the same conclusion, but they have given different proof of that. So just to mention that I was not able to find that proof, but maybe if somebody is able to observe that, then that is also very much appreciated. So what they observed is that if you look at this triangle DEF, right? So they mark these three triangles, okay, which are all congruent. Okay. So this, I'm marking them in this light blue color. So their observation is that all these three triangles are congruent. Why? Because firstly, like by SAS test, that in each case, two sides are equal and the angle in between. So all of these angles are 150 degrees. So this angle is 150 degrees. This angle is also 150 degrees. And this is also 60 plus 90, so 150, right? So therefore, all of these triangles are congruent, and therefore, what will happen? The corresponding side, like the longest side of each of them, right? So this is like this side. So these are going to be equal in length. So therefore, basically D is the point which is equidistant from AFN. Okay, but at least when I tried the problem, I was not able to see this proof. But yeah, but that is not the only approach. Like even this way you can do it. That you just take the perpendicular bisectors of two of the segments, and wherever they meet, that is where your circumcenter has to be. Okay, so this is one of the reasons why I would say this is a very hard problem, because realizing that that point D is the circumcenter is the sort of the main critical point, which may take up a lot of time. Okay, then what is asked actually? So now we want to find the radius. We want to actually find the length of this radius. How much is the AD, like how much is this actual? What is the distance of D from all the three vertices? And what is given is the length of this side. So this is what is given. Okay, so this can be done after you realize that we have to find AD, then it is a relatively simple thing. So if I just focus on this upper part of the diagram, okay, ignore everything else. Suppose I have just an equilateral triangle and a square. Then so in this, what is given is I know the length of the sides, right? I know all these are equal, and I know the value of that. What is that is given? Very complicated expression. 15 by. So let me just call it A temporarily instead of writing the expression every time. I'm just going to call it A. Okay, and then can we find the length of AD now? This, how will we find AD? Can somebody tell?
30, 60, 90, 10.
Yes. So so the way I did it is that if I drop this perpendicular, right, to the base, right, then and if I call this point something x and y, let us say, then you see that so xy is also A, right? That is the same as the length of the square because that's just the distance between the two opposite sides of my square. And ax is root 3 by 2 times A. Why? Because that is just the altitude of the equilateral triangle. So again, by 30, 60, 90, you see that ax is root 3 by 2 times. And how much is dy? So dy is, because again by symmetry, everything is going along this vertical line. So it is going to perfectly divide the base into two equal parts, right? So dy is nothing but again half of A. Okay. So therefore, I can apply Pythagoras theorem in triangle AYD. So I'm going to get AD square is equal to AY square plus YD square. Okay. And so now if I everywhere I will substitute the values. So AY is AX plus XY, right? So it is and YD is okay. So this is AD square. And so if I, so you see firstly that I can take A common, like A square common from everything. So if I keep A square outside, then inside the bracket I will have root 3 by 2 okay, and I can just expand this. So let me skip the expansion, like do it quickly in your mind. So this is root 3 plus 2 square and plus 1. So root 3 square plus 1 square plus 2 into 2, 4 root 3 plus 1. So this is, it is 5 plus 4 root 3 by 4, right? Times A square. So this is AD square. Somebody has asked something in chat, maybe. Somebody has raised their hand. I don't know. Anyway. Okay, so therefore AD square is this much. And so now I'll substitute the value of A. So A is how much? 15 upon this one. So therefore square of that. So 15 square upon 2 plus root 3 into this. Oh wait, I think I made a mistake here. Yeah, so when I squared here, I should have done it 3 square plus 4, 2 square. So that is 4. Okay, so this is 8 plus 4. Okay, so I'm not bothering to explain the calculation because I think uh, sufficient time given, everybody will do it accurately. So now you see this is going to cancel with the base, and therefore AD square is 15, and so AD square is 15 square, so AD is 15. Okay, is that the answer? Yes. Okay. So overall, I mean, just the bottom line is that this is a difficult question to solve in the given time. So in general, I would say that quickly try draw the diagram, observe that it is complicated, and move on, and come back at the end if you have time. And there also again, when even if you have time at the end, you should prioritize that. If you have one question like this and some another unsolved question, then which question seems to be more gettable, right? Which question seems to be more doable. So I'll give priority to that question. So in the end, I might even completely skip trying this question. So it depends on lots of factors, obviously. But yeah, let me just pause for 1 minute if you want to copy anything.
Sir,
Yes.
I have a question. I was solving the January 2022 question paper, and there's a
Oh,
geometry question about a square.
okay, but wait, just a minute. So I don't have time to discuss any other question apart from this paper actually. So maybe after, if you can wait, tomorrow is our last class, right? So after that, if you wait, I will look at your other question.
Yes, sir.
Yeah. Okay.
So can you
Okay.
show the question once?
Oh yes, sorry. Okay, so I mean that is why actually I kept this question as the last geometry question. Uh, so then maybe we can move to the next, the non-geometry section now. So within the non-geometry topics, the sort of the more important topics I would say are, you'll see that half of the questions are focused on, or probably more than half the questions are focused on basic uh, knowledge of factorization, quadratic equation, and things like that. And some questions are based on sort of miscellaneous topics such as sequences and series, or algebraic expansion. But very roughly speaking, uh, yeah, this is like the two major areas of algebra that you should know. So for question 23, for example, yeah, let us see this in more detail. Okay, so what is given is there is a sequence of elements or a set. So SA1 is 1. Okay, so there is some pattern which is given, right? So if you observe, every set has alternating positive and negative terms. Okay, and the number of terms is increasing. So first had one term, next had two terms, third has three terms. So you see, every set has one extra term. And so on and so forth. Okay, and then the question is, so they are asking about the set A of 25. So A of 25 will also be some such set with. So you see, A1 has one element, A2 has two elements. So like that, A25 will have 25 elements, right? And we are interested in the sum of the elements. So sum of elements of A25. That is what is S, okay, which we want to find. So we need to start making some observation that, okay, what is happening in this pattern, that what can help us to find the value of this A25. So because the alternating terms, you see how the alternating terms are, let us look at A5 for example. So they are alternating with sign, and the value is also increasing by 2, right, the magnitude, right? So if I just take this pair, right, 21 and minus 23. Okay, so what is the sum of these two together? You see it is minus 2, right? Because it is like going ahead by 21 and then coming back 23. So the net displacement is minus. And you see that is going to happen with every pair. Like this pair again, 25 minus 27 is minus. So like that, every pair is going to, every time you see that, every pair is giving a answer of minus 2. So in my 25 elements, you see I'm going to have this kind of pairs of minus 2 minus. How many such pairs will I have total? I'll have 12 pairs, right? So I'll have 12 pairs whose answer is minus 2, and then one last element will be remaining which doesn't have any pair. Like how for A5, the last term did not have any pair, but before that everything got paired up. So therefore, my what the sum S which I am interested in, it is, so I don't even need to find all the first terms because they are just going to sort of cancel each other. So the S is just going to be minus 2 repeated 12 times and plus the last element. Okay, so that is minus 24, and so all I need to find out is the last element. If I find the last element, then I know the sum, the entire set. Okay, okay, then how do we find the last element? So if I now look at just the last elements of all the set, right? So if I write them in here, so here the last element of the first set was 1, then it was minus 5, then 11, minus 19. Oh, sorry. Okay, so these are the last elements. So I want to find the 25th element in this sequence. So so these are all odd numbers, right? So can you tell me that when I say odd numbers, so let's say we are talking about natural numbers. Okay, so in natural numbers, I can say 1 is the first odd number. So here, like, let me write here. So the first one was the first odd number. What about 5? Like, let us ignore the sign for now. Just look at 5. So what is the index? That 5 is the which odd number? Like in
Third.
one third, right? It's the third odd number. What about 11?
6.
6, right? So in general, you see the pattern is this is the 10th odd number, and this is the 15th odd number. So if you look at these numbers, are they reminding you of something? Have you seen this pattern? 1, 3, 6, 12.
Triangular number. Triangular
These
number.
are triangular numbers, right? I had done this at the very beginning last time, that we had said that the nth triangular number is the sum of 1 plus 2 plus 3 up to n, and the formula is n into n plus 1 by 2. So therefore, this 25th element looks like, if I find the so the notation is, so this is T1 is the first, or T2, T3, etc. So like that, T25, whatever I get, right, I have to find that number, odd number. So what is T25? That is 25 into 26 upon 2, right? So that is equal to 25 into 13. Okay, so that is 12, 325. So I need to find the 325th odd number, and that will be my the number which I'm looking for. Okay, so how do I find the 325th odd number? That how do you find the kth odd number? What is the formula for the kth odd number? It is 2k minus 1. Okay, so you can check that in this works. Like the first odd number is 2 into 1 minus 1. Second odd number is 2 into 2 minus 1. Like that, the kth odd number is 2 into k minus 1. So therefore, this 25th element I'm interested in is 2 into 325 minus 1. Okay, so that is 649. 649, no? And then what about the sign? So sign is just alternating, right? The first was positive, second was negative. So you see every odd position has positive sign. So first, third, fifth, like that, 25th will have positive. So therefore this is positive. So this was the last element of my set. So this last element which I can plug back into my this expression, and so therefore I'm going to get this as 649, and so therefore my S is 625, and what they've asked is find the square root of S. So square root of S is 25. Okay, but this counting was important, and like, so again, to repeat this problem, what were the important observations? First is understand that we don't really need to know the values of all the elements, because most of them can be paired up like this, where the sum is minus 2 minus 2 minus. So we are going to get 12 such pairs of minus 2, and so their total will be minus 24, and then plus the last element. And so to find the last element, we looked at all the last elements up to A25. Yes, Harshvardhan.
Sir, can you explain that why S is equal to -2 into 12 plus last element?
Because if you look at, take A5 as example, right? If you look at A5, what are the first two terms? 21 and -23. So their sum is -2, right? And so like that, every consecutive two elements are having a sum of -2. So the same pattern will be true for A20. So A25 has 25 elements. So ignoring the last element, the remaining 24 elements will be grouped into pairs like this. So that I'll get 12 such pairs, right?
Yeah, yes, sir. Okay.
Okay. So then again, to repeat the logic of how we computed the last element. So we looked at all the last elements like 1, 5, 11, 19. Maybe it would be better to write it as a table. So like A1 has the, what is the last element of A1 was 1, which is the first odd number, ignoring the sign for now. So A2, the last element was 5, which is the third odd number. And so here this number 1, 3, these are all triangular numbers. So this is 1 is nothing but T1. This is T2. T3 is 6. So therefore the A3 has the sixth odd number. Okay, so that was the pattern that we observed. So for A25, the whatever number we are going to get will be the T25th odd number. Okay, so T25th odd number. Okay, and T then we found T25 as 640. Sorry, 325. So we are interested in the 325th odd number, which is 2 into 325 minus 1. So that is what we got here. Okay, and then once you get the last element, then you come back to the original calculation and find the answer. Okay, so you see it was a, within one sequence you had one more sequence, and within that sequence you had one more sequence. So it was that kind of a convoluted problem. But if you just observe carefully and take the pattern, sort of complete the pattern, you will get the answer. Okay, is this clear? Any doubt? Okay, then there is one more question also on the sequence, the answer or topic of sequences and series. Question 24. Okay, so in this question, again there is one more sequence involved. So you have set S1, S2. So this time the terms are, once more you'll observe that the set is becoming larger in size, like S2 has two elements, S3 has three elements, like that. But now the numbers are decreasing. And so on. And they are asking us to find something about the S63. Okay, find the middle term of S63. Okay, so S63 will have how many? 63 elements, correct? Okay. Okay. So one very easy way to solve this problem I find is that let us just look at the last elements. Okay. So 2024, 2022, 2019. Let us write one more set in this order. So 2018. Okay, so suppose I make a table of just the last element. Okay, so here I have n and let us say ln to indicate the last element. Okay, so I'm just going to make a table of the last element. So for the first set, the last element is 2024. For the second set, it is 2022. So if you look at the distance, right? How much gap is there? So here the gap is 2. Here the gap is 3. Here the gap is 4. So you see somewhere again this looks like it is going to be related to triangular numbers, but it is not clear, right? Like what is the, these are clearly, these are not triangular numbers, but can I through some clever adjustment relate this to triangular numbers? That I know the triangular numbers as 1, 3, 6. Like if I just write triangular numbers over here, right? 1, 3, 6, 10. Then they also have a gap of 2, gap of 3, gap of 4, right? So if I, so Tn, so these are the triangular numbers for the same position. So can, the only thing is here they are decreasing and here the triangular numbers are increasing. So if one sequence is decreasing, another sequence is increasing, how can I combine them? Can somebody think of some way by which I can combine these two columns? What can I do?
Writing it in reverse order.
Okay. So my idea is like that. If I write, so from here to here, I have, what is the change? The change is -2, right? So basically from here to here, I'm going -2, whereas from here to here, I'm going +2, right? So you see, whatever I'm doing here, I'm doing the reverse operation here. So that, so this step, I don't have any explanation that why I thought about doing this. Maybe just by solving so many questions, this comes to me that what if I write the sum of these, like for every row, if I write the sum, right? This plus this, how much am I going to get? Second row, third row. So see, every row is adding to 2025, and the reason for that is simply that how much you are decreasing. Like let's say from this to the next term, here I'm going to do -5, right? And here I'm going to do +5. So obviously the total sum is going to remain the same. So in general, for every term, this plus this is to 2025, and the same pattern will continue all the way. We are interested in S63, right? So 63rd row, right? So whatever I'm going to get L, the last element of the 63rd set, and T63, there is one will also be 2025. Okay. So I would say this is the fastest way to solve this problem. There are other ways also, but I think this, uh, if you, I want to deliberately show this, clever tricks that if you solve questions in this way, you can make, you'll have some competitive edge. Otherwise, if you do the same thing that everybody else is doing, then you will not be able to, beat them in the competition. Okay, so if you observe this, then we can directly find L63, right? So L63 is nothing but 2025 minus T63. And T63, we know the formula, n into n plus 1 by 2. Okay, so the value I get is 63 into 32. 6, 12, 20. Okay, so I get L63 as simply 9, which means the last element is 9. Okay, but again, don't be in a rush and write 9 as the answer. What they have asked is not the last term, they have found the middle term. So we are interested in finding the middle term of this set. Okay, so how do you find the middle term from the 9? So obviously from the end of the sequence, it will be increasing, right? 9, 10, 11, like that. So I have to keep on increasing until I reach the middle. So how many turns will I have to go to reach the middle of my set?
21.
21 का बरो? Isn't it half of the 63?
Plus
If you take an example,
31.
31.
31 na, huh? So like basically if your set is of, like if you take a small example of S5, so S5 चे 5 element आहे. When S5 is involved, from the last element to the middle term, I have to increase by +2. So again observe the pattern that for S5 it is +2, for S7 it is going to be +3. So like that, for S63 it is going to be, so whatever is this number, right? If you observe, I need to go to half of that, right? So 5 the half is 2.5, but obviously that 0.5 I have to skip, so I'll be just going up to 2. So like that, for 63 I have to go up to half of 63, which is 31.5. But again, that 0.5 I have to ignore and just go 31. So therefore the answer is 9 plus 31. Okay. Or one more way to find the center point is that you find the average of the first and the last term. So I find the last term as 9. I'll find the first term as 9 plus 62. Why I did 62 and not 63? Because this is a standard sort of trick. When you have 5 elements, the distance between the first and the last element is not 5, it is 4. So in that way, we have a 63 element set. The distance between the first and the last element is not 63, but it is actually 62. So the first element is 9 plus 62, which is 71. And then the middle term will be the average of 71 and 9. So again, I'll get the answer as 40. So yeah, both methods are valid. Okay, but so all of this was because of this observation that we write the last element like a table, and then you observe that these values are decreasing with triangular number. The intervals between these are decreasing in the same way in which triangular numbers are increasing. So therefore, I can say ln plus tn is constant throughout, and so therefore I'm able to get the value of 63 L63 directly. Okay, so I'll just wait for 1 minute if I want to copy anything. So all of these topics I have to give you at least 1 or 2 practice problems in my the practice paper, so that should give you additional uh, practice to solve this question. Okay, then going to the next problem, question 25. So what is given? X and y are integers such that x greater than 5, y greater than 3, and some equation is given. Okay, so as a first step, what we can do is, let us try to get rid of all the square roots. So if I just square both sides, what I'm going to get? So on the left hand side, I'm going to get x minus 5 plus y minus 3 plus the middle term. And on the right hand side, just x plus y. And you see, so therefore x plus y is going to get cancelled from both sides. And if I just bring this 5 and 3 to the other side, I'm going to get 2 times 8, or in other words. Okay. So again, if I square it again, so basically whenever I have square roots, I need to keep squaring until all the square roots are removed. Okay. And now this x and y, the fact that they're integers, that is very important, that these are integers. So that means that of course these are also integers. So then I just need to consider what are the ways to factorize the 16 into these two terms. And so here, this information they are given also important, that x is greater than 5 and y greater than 3. Or in other words, x minus 5 and y minus 3, they are both positive. Or yeah, not negative, but positive only. They cannot be 0. So therefore, I need to consider only positive roots. Otherwise, I have to consider negative. If this information is not given, right, then my problem becomes more complicated, because I have to consider, for example, minus 2 into minus 8 also. But we don't have to bother with that because everything is positive. So the only factorizations that we need to consider are 1, 16, 2, 8, 4, 4. Okay. So these are the values of x minus 5 and y minus 3. Then corresponding to that, let me write here also. So for each row, if this is the value of x minus 5 and y minus 3, then what are the values of x and y respectively? And finally, what is the value of the product xy? Why? Because they have asked the question, find the minimum value of the product xy. So I have to, every case I have to find it. So in the first row, for example, if x minus y is 1, so is x is 6 and y is 19. In the second row, for example, x is 7 and y is 11. The third row, x is 9 and y is 7. And so in each case, I need to multiply and check that, which is going to give me the smallest value. Okay. And so here, generally the pattern is that the value will start with something very high, it will reduce and then it will increase again. So somewhere in between the minimum will occur. And here, this row 9 7s are 63 will give you the smallest value. Of course, we have to, of course, calculate all the values to confirm. But typically, that is the pattern, that the endpoints will have some extreme values, and somewhere in between you get the right answer. So the answer is 63. Okay, so I'll definitely consider this as one of the simplest questions, that this should be a time saver for you. That quickly doing this calculation, quickly squaring and getting rid of the square root, factorizing 16 and checking the answers uh, manually until you get the right. Okay. If no doubts about this one, then we can quickly go to the next problem. I'll just wait for 1 minute. Okay, so this question 28. So this is a question mostly based on your knowledge of algebraic expansion, like factorization and things like that. So like, what is the given information? A square upon, okay. So first thing we always try to do is we want to keep the denominator factorizable. So here the denominator looks more complicated than the numerator. So first thing we should try to do is reverse the situation. Okay, so if I just make the reciprocal of both sides. Okay, and the reason for doing this is that now in the next step you'll see what is going to happen. Now if I just expand this, like, the into separate terms, then what are the terms? The first term is a raised to 4 upon a square. The middle term is my a square upon a square. Okay, and so if you look at a form like this, it should remind you of one identity which you probably must be doing in school already. Like, when you have a plus b bracket square, which is a square plus 2ab plus b square. But if one of the terms, like b, is the reciprocal of a, then what happens is this middle term sort of becomes a constant, right? So a plus 1 by a square is a square plus 2 plus 1 over a square. Okay, most likely I think this you must be doing in school already. So this is looking a lot like that, right? So that should remind you that, okay, with some adjustment, can I make this a perfect square? So if I just look at the middle term, right, this -1, if I uh, so I can convert this into a, if I subtract one more one, it will become a square minus 2 plus sorry, a square minus 2 plus 1 over a square. Okay, so that is a minus 1 by a bracket square. But so this is where some sort of forethought or planning could be useful. That if you notice what is happening in the RHS, right? If I subtract 1 from this, right, I am to get 33 upon 4, which is not looking like a perfect square. But on the contrary, if I want to convert this into the positive one, so if I add 3, so that -1 becomes +2. Okay. Then what is happening to the RHS, that if I add 3 there also, I'm going to get 49. So now that is looking like a much more manageable calculation. Maybe even with this one, you can somehow struggle and find the answer, but it is all about, we want to be efficient. So always pick, whenever you have a choice like this, don't be in a rush that, okay, -1 looks so close to -2, we'll quickly make that change and proceed, but then you will get stuck. But if you just pause for a couple of seconds and observe that my +2 is a better approach, then this is a plus 1 over a bracket square is 49 by 4. Okay, and here important again, the question has given a is a positive real number. So when I take the square root, I don't need to bother with the negative sign. Otherwise, I have to consider 7 by 2 as well as -7 by 2 as two separate cases. But here I'm just able to work with the positive case. So I found a plus 1 over a. Okay. And what have they asked? So you see, what they have asked is also of a very similar type, right? This is, if I take the reciprocal over here, this a raised to 6 over a cube, that is again going to become like a cube and like that. So this is looking very similar to that. Okay, so if I write what they have asked over here, so if I just take the reciprocal of that, okay, and if I expand it, I'm going to get a cube minus 1. Okay, so I'm interested in finding this a cube. So the -1 is not important, but I need to find a cube plus 1 over a. And what I right now have is a plus 1 over a. So how do I go from here to here? So any suggestions? What can I apply here?
So we can expand it and just
Oh, yeah, okay. Using which
So we
identity?
can,
a cube plus b
we
cube
can take a plus
by
1
a plus
by
b
whole bracket cube.
Yes, correct. So actually both approaches are valid. So one idea is you take the whole bracket cube and then you will get some middle terms which you can calculate and you'll get that way. And the second approach is you use the a cube plus b cube identity. Okay? So both ideas are valid. So if I take this as a cube plus 1 over a bracket cube, so this is 1 over a bracket cube, then the identity is a plus 1 over a times a square minus the product a into 1 over a, which is simply 1 plus a square, right? And here I know everything now, right? This is a plus 1 over a is 7 by 2, and luckily this term is exactly what we had computed earlier at this step, right? So I can directly plug in the values to get the answer. And alternately, if you decide to cube this, that is also fine. You are going to get a cube plus 1 over a cube, and the middle terms will be 3 into a plus 3 into 1 over a. Okay, so again here also you know everything. So a plus 1 over a is nothing but 7 by 2, and on the LHS you have 7 by 2 cube. Okay, so again with rearrangement you can get the value of the middle term. Okay, so both approaches are valid. In the end you are going to get the same answer. Okay, and so by the way, this what you are going to get is m over n. Okay, so if I let me continue here. So sorry, n over m. So n over m is 7 by 2 into 37 by 4. Okay. And what have they asked us to find? Minus 3 by. So if you see here, actually the they are co-prime, right? there are no common factors between numerator and denominator. So actually I can say that n is the numerator and m is the denominator. So that is so therefore n minus 3 is 256. 64, right? No, sorry, 32. Right? 32. No, 32. Sorry. 28. Right? I think I made some calculation mistake. Can you just check if I made some mistake somewhere? Why? Because I'm supposed to get the answer as 31, not 32. Might somewhere there is some calculation mistake. But anyway, at least the answer key which I copied has the answer as 31, not 32. Can somebody, has anybody done this problem? You got 31 or 32?
Yes, 31.
Right? Half of you are saying 31, half are saying 32. Did I do this multiplication correctly? 7 7s are 49, 4 carry over, 7 3s are 21, 259. 259 minus 3 is 256. Divided by 8 is 32. But even last time I had solved this problem. There I got the answer as सकता होता है. Okay, let me just for confirmation, let me solve this other method. Am I getting different answer or the same answer? So if I continue this, I'm going to get a cube plus 1 over a cube is equal to 343 by, I think last time I had used this method, but I think both methods are valid. So I'm going to get 343 minus 84, which is 33 minus 8 is 20. So, 259 by 8. Okay, so I'm getting the same value of n over m. But for some reason,
Sir, we have to do
Mhm.
-1 also.
-1, why? There we have to -1. अरे हाँ, yes, correct. हाँ, correct. इधर -1 है तो विसरलो. Yes. So this -1 I forgot. So actually, what we found here is a cube plus 1 over a cube is this. Okay. Therefore, -1 of that will be 251 by 8. So which means n is 251 and m is 8. And then n minus 3 by m will correctly come to be 13. Okay, you see how sensitive this exam is. Honestly, like as I said earlier, so I come from Olympiad background where we give marks for each step. So the unfortunate thing is that objective exam like this, even if one small -1, if you miss, you write, and 32 looks like such a nice number. It looks like the answer, right? And you write it and you move on. Sometimes you don't even have the time to check your calculation. So that is the unfortunate reality of some papers like this. But so the solution is to adapt that, understand that you need to be more focused, more calm when you solve the paper to avoid calculation mistakes like this. By the way, have you seen this video from Subodh Pete sir about how to avoid silly mistakes? I will send you this YouTube link, okay, on the WhatsApp group. This is a very interesting video that Subodh sir has recorded and put on YouTube. That what students can do to fix your, because many students may have this problem, right? You make calculation mistakes and you lose marks. So how to overcome that? That is very important. Okay, but anyway, so question 27. So what is given is some expression and what they have told is that this is the perfect square of some polynomial. Okay. So can somebody suggest how we can proceed?
So we can write the polynomial as x plus qx plus r raised to the power 4.
Um,
So
re-
just
re-
just x.
okay. No, but why would it be raised to the power 4? Because what I'm given is this is a perfect square. I don't know if it is something raised to 4. So
Yes.
my idea is that I can equate it with this expression. So I will write my polynomial as x square plus qx plus r. And whether here also, why did I choose x square? Like, how do I know that the coefficient of x square is 1? Because x raised to 4 is 1, right? So therefore, that kind of, I'm just simplifying one step. Otherwise, technically, if you we should write this as p, q, and r. And because we don't even know what is the coefficient of x square, but at least, so one step I'm sort of skipping. Okay. But still, I need to find the values of q and r so that this matches. Okay, so now let us just take the perfect square of the right hand side. So I hope that you know the identity a plus b plus c bracket square. So that is the square of the individual all the terms. Or rather, I'll show a slightly different way of doing this more efficiently. So if I just write x square plus qx plus r, two times one below the other, and we try to do it in this way that we look at every power of x and see which terms are going to contribute to that. So for example, for the constant term, right, I will only can pick r and r, right? So r into r square has to be the constant term. No other term can be used to get the constant. Then the term which has x in that, so in that the only possibilities are this kind of cross multiplication, right? You multiply this with this, so qx into r, or this into this, qx into r. So if I combine both together, I will get 2 times q into r. Okay. And so in this way, you will save some time doing this calculation. So x square, for example, how many ways are there to obtain x square? You will multiply this x square with r like here, or you multiply x square with r like this, or you multiply the two middle terms like qx and qx. So each of them is going to give you x square. So so what is that going to be? 2r plus q square, right? So like that, you see how this is much more faster than expanding the bracket using a plus b plus c bracket. What about x cube? So x cube can be obtained by x square into x. So again, just to be clear, let me use a different color. So here, this 1 into q or 1 into q. So both of them is going to give you x cube. So therefore, I'm going to get 2q. And finally, x raised to 4, obviously, I mean, the only way is small into 1. So you're going to get 1. So therefore, the sum of all of this is my RHS. And that has to be equal to my LHS. So if I write it term by term, right? So the x raised to 4 has to match with x raised to 4. X raised to cube has to match with this one. Then plus a square, ax square plus 12x plus b. So if I compare the coefficients, I'm going to get all the information I need. So basically b is equal to r square, right? Then 12 will be equal to 2qr. Then capital A will be equal to this 2r plus q square. Minus 4 is equal to 2q. And then last one is equal to 1. That doesn't give me any information. So I have all these four pieces of information available. And finally, what I need to find? I need to find b minus a. So if I need to find b and b minus a, I need to eliminate everything else, right? I need to get rid of q and r. So now this is just algebraic, like solving simultaneous equation. So here already I can see that from the last row, like minus 4 is equal to 2q. I'm able to obtain the value of q, right? So therefore q is simply minus 2. So I can substitute that in the other equations, like for example, in the second equation, 2QR. So therefore, R is nothing but so I found the values of Q and R. So therefore, B, which is R square, is 9, and A, which is 2R plus 2 square, will be -6 plus -2. So therefore, B minus A is 11. So that is my answer. Okay. So again, the sort of the critical, and this is again the time saving way to do is quickly, right? If you want to square a polynomial, you do it in this kind of a grid fashion. By the way, this same, I don't know if anybody has studied Vedic mathematics tricks, then this same pattern is used to multiply two three-digit numbers. Are you aware of this trick? Like if I want to multiply two three-digit numbers, 121 or 123 multiplied by whatever, 412, let's say. Then the same pattern is used. Like you first multiply the units place digit, then you cross multiply the tens place digit. So 4 plus 3, 7. Then you cross multiply all the three places together. So 1 into 2, 3 into 4, 2 into 1, and so like that. You proceed in the same way that what we did here to get each place. Okay, I'll just pause for 1 minute if you want to copy anything. Okay, then moving to the next problem. So again, another problem related to polynomials. I think this question 28 is very simple. Again, should be a time saver. Almost without even writing any calculations, you can finish a problem like this. So, what is given is some px is 3x square plus kx plus 117, and you're just given the values of this polynomial at two different. So p of 1 is equal to p of 10. So if I just put the values of x equal to 1 and x equal to 10, I'm just going to get the equation directly. Okay. And so here you see 117 is just going to cancel. So I'm directly going to get the equation of 9k is equal to minus so k is simply this divided by 9, which is 333, right? Minus 33. So therefore I know the polynomial. The polynomial is nothing but 3x square minus 33x plus 117. And so if I just put the value of 3, I'll get the answer. So I think this is definitely one of the simplest questions. What is answer? 45. Okay, I think everybody should be able to follow this without much difficulty. Okay, if this is clear, then let's go to the next question, because actually the next question is introducing one very important property about polynomials, which again I don't know if all the school boards already emphasize this sufficiently, but if not, I would like to spend some time to explain what is happening in this question. So whenever you have a polynomial, right, and this applies to any degree polynomial. Here we are talking about cubic polynomial, but in general, we already saw this for quadratic. So maybe just to revise the property for the quadratic equation once more. So if you have, in general, for a quadratic equation, suppose ax square plus bx plus c is equal to 0 is my equation, and the roots are alpha and beta. Then the question is, what is the relation between the roots and the coefficients? So the ABC, which are the coefficients, and the alpha beta roots. So if alpha beta are the roots, the observation is that again we are not right now able to prove this because of time, but basically this quadratic equation has to be equivalent to this one, where if you take the a common and then you have x minus alpha, x minus beta equal to 0. So if I expand this, the bottom one, I'm going to get a times x square minus uh, again, if you look at the terms which are contributing to x raised to 1, it will be a times alpha plus beta x, and the constant term is a into alpha beta. And because this is the same as the original one, so if I compare the coefficients, basically this coefficient has to be equal to b, and this coefficient has to be equal to c. Okay, and if you rearrange this information, the conclusion is that the sum of the roots alpha plus beta is minus b by a, and the product of the roots is c by a. Okay, so even if you don't know the values of the alpha beta, you can find a sum and the product from directly from the coefficient. Okay, so the same thing can be extended to other polynomials also. Like for example, in this case, question 25, we have a cubic polynomial. So if I have a polynomial, and for simplicity, let us assume that the coefficient of the leading, like the x cube, is 1. Otherwise, you can always divide the whole polynomial with that coefficient to get it to be 0. Okay. Let us say the coefficients are px square, qx, and r. Okay. So suppose this is your polynomial. Okay. And let us say the roots are alpha, beta, gamma. Or in this question, they use ABC. So let us use ABC only. Doesn't matter. Okay. So suppose your roots are ABC. Then again, the idea is that, so here the leading coefficient is 1, so I can ignore that and just equate this to my x minus a, x minus b, x minus c product. Okay, so these two have to be equal. And so to compare them, I will expand the lower term again. So you see x cube I will get, then x square. So observe how x square is constructed. So x square will have 2 copies of x and third copy of the one of the ABC. And so like that, in a cyclic way, every ABC will occur once. So total, if I combine all of them, I will get minus a plus b plus c bracket into x square. Okay. Then what about x raised to 1? For x raised to 1, you will see that I have to take one copy of x and the remaining two will get multiplied. So b into minus b into minus c, which will become plus bc. And like that again, cyclically, if I write all of them, I'll get basically 2 at a time. I have to take two of the two of the roots and multiply them. And finally, the constant term is just minus a, minus b, minus c, all multiplied together. Okay, so again, if I compare this term by term with my original equation, you'll see that what I'm able to do, right, is this is equal to p, this is q, and this is r. And so again, if you simplify that, the conclusion is that the sum of the roots a plus b plus c is the minus p, the what is called a 2 at a time, multiply 2 at a time and then add them together, that is equal to plus q, and the product of the roots is minus 1. So this basically alternating sign, minus plus minus, is there. And once more, we have not actually found the values of ABC. without even finding the values, I'm able to say how much is the sum of the roots and the product of the roots, for example. Okay, and this pattern continues beyond cubic equation also for fourth degree, fifth degree. So there is a if you are curious to read more about this whole properties, these are called Vieta's relation. If you Google this term Vieta relations, you will get the sort of technical proof of any nth degree polynomial. What is the general pattern over here? But I think for our purposes, it's enough to just know up to the square and the cubic polynomial. Okay, so if you understood this, then we can now again let us look at the question once more and see how to try to solve that. So in the question, if you observe what they have given is uh, like this polynomial which is expanded is equal to this one, which means you can make the term by term comparison, right? So this minus a plus b plus c is equal to 6, for example. And like that, you can make the term by term comparison. And okay, and but the thing is, what they are asked to find is something very strange: cube root of a, cube root of b, and cube root of c. Okay. So actually, this is a very special question that they have deliberately designed this question in a particular way, where some special tricks can be applied. In general, this could be a very hard question. That from ABC going to cube root of a, cube root of b, cube root of c is not simple. But luckily, this question has one trick involved. Okay, so so what happens here is that if I look at the equation, let us look at the polynomial more closely. Okay, so okay, um, and what we know is ABC are the roots. But when I say something is a root of the equation, which means that ABC satisfy this equation, right? So instead of x, if I write a, then this equation is satisfied. And similarly for B and C. So all of A, B, C, all of them satisfy this equation. That is what we mean by when we say A, B, C are the roots of this equation. So like let us just look at A, for example, that I have written this expression for A. And I'm curious that can I some way find cube root of A out of this? Okay. So to find cube root of A, I have to take the cube root of the equation, right? Obviously. Only then I'll get the cube root. But if I directly try to take the cube root, then all of these terms are going to interfere. So, so I would like a to be on one side and equal to something else, and then I'll take the cube root. So I'll get cube root of a is cube root of whatever is LHS. And if I'm lucky, this LHS is already a perfect cube, so that this becomes a nice answer. That is what I'm hoping to achieve. So if that is the direction we want to go, then from here, how do I proceed? That what should I do here to reach that? So we'll observe that actually the LHS is almost a perfect cube. Okay. If I write, so for example, the first thing we notice is that this plus 8 is 2 cube, right? And if I wanted to write a plus 2 cube, what are the terms going to be? It will be a cube, 8, and the one of the middle term will be 3 times a into. So you see, this is exactly 6a square. And so the only other term which is not matching my original is this second term, right? So that is 3 into, so this is 12a. So a plus 2 bracket cube is this much, whereas my polynomial is this. So you see the only term where it is not matching is this one. So that is giving me the hint that, okay, what if I make this change that as you know, we have the trick for completing the square. In the same way here, we are doing completing the cube. Okay? Completing the cube. Okay. So to complete this cube, I need to change this term to plus 12, plus 12a. So let me just add that to both sides. So you see how this is a very special question, that otherwise generally if I give you any polynomial of third degree, it is not going to look like a perfect cube. Like here just one term was incorrect, so to say. And so if I make that adjustment, now you see that you should be able to proceed from now, because now like basically LHS is now simply a plus 2 bracket q is equal to 64a, right? And now if I take the cube root of both sides, I'm going to get a plus 2 is equal to, and cube root of 64 is 4 conveniently. And so I'm going to get a plus 2 is equal to cube root of 4 times cube root of a. And whatever we did for a, we can do the same thing for b and c also. So basically, I can write all these three. And if I add them, I'm to get this, the sum which I am interested in is equal to a plus b plus c plus 6. And out of this a plus b plus c I already know, right? Because if I compare the coefficients, I already we have seen minus a plus b plus c is equal to 6. So therefore a plus b plus c is actually minus 6. So therefore this term is simply minus 6 plus 6, which is 0. And so the answer which I'm looking for is actually just 0. Okay, but the approach to reach that 0 was very interesting. That what we had to do was look at, so again this is, I would say, one of the more harder questions, because it requires this special observation that you have to be really attentive, that look at this, it is looking like almost a perfect cube, and if I adjust this term, it is actually going to become a perfect cube. And then after that I'm going to take the cube root of this expression, and then if I add the ABC together, I'm going to get the final answer. So yeah, I think this is a kind of a very special problem. Okay, we are out of time, so we'll stop here. But so next time we'll continue with the what are remaining questions there are here, and after I think just 2 questions are remaining. Yeah. So then after that we will discuss the practice paper, which I will send to you just after the in just a few more minutes. Okay. So again, same as what we had done for the previous 2 like physics and chemistry paper, what you should do is try to solve that paper with time limit first, and then again try to do the same paper without time limit to see if you are able to get the problems given sufficient time. Okay, I think that's all for
Yes,
today.
sir.
Thank you. Bye.